Hey guys, so there's no video notes for what we're doing today, just simplifying radical and rational expressions. But I wanted to work just a few equations really quick, just to kind of go over it with you. So what you're going to do, the whole point of simplifying is to get rid of the square roots. This was the original equation. I just kind of already went ahead and got started. They want us to simplify this. Now, the first thing we have to do is change the sign in between and multiply the denominator by its opposites, right? And then whatever we have to do to the denominator, we also have to do to the numerator. So I've gone ahead and rewritten it as the square root of 3 plus square root of 7, and then we have square root of 3 minus the square root of 7 over here. So this is the original. All I did was change the sign in the middle. We're going to multiply the numerator and the denominator by it. You do not have to change the sign of the first one. And you'll see why the square roots will cancel out. We're basically trying to get rid of any negatives and any square roots in the denominator. And I'll show you an equation down here where there's only one and how that works out as well. So when we multiply those out, the square root of 3 times the square root of 3 is going to be 3. Please make sure that you aren't squaring that or multiplying them by each other because we're multiplying their square roots. And then you end up with plus the square root of 21 minus the square root of 21 minus 7. All right, and this is why we multiply them by the opposite, because those will end up canceling out. So our denominator ends up being -4. And we're going to get rid of that negative in just a minute. Let's finish out the top. So we have 7 square roots of 3 plus 7 square roots of 7. So again, 7 square roots of 3 plus 7 square root of 7, because we can't simplify that any further. Now I want to get rid of this negative sign underneath, so I'm just going to flip all of the signs. When we take it away, we just have to add it to each portion of the top. So we get -7 square root of 3 minus 7 square roots of 7. And this would be your simplified expression. I'm going to do one more over here where you can see that we only have one root. So we're going to multiply the denominator by 10 minus the square root of 2 and the numerator by 10 minus the square root of 2. All right, once we do that, we get 100 minus 10 square roots of 2 plus 10 square roots of 2 minus 2. All right, and then on the top, we have 80 minus 8 square roots of 2. For now, I'm going to leave that as 80 minus 8 square roots of 2, and then the bottom would be 100 minus 2, which would leave us with 80 minus 8 square roots of 2 over 98. Now, this problem isn't on the examples in the Padlet, but I just kind of wanted to show you another one where it looks like this instead of this. You'll see them like this. Now I could keep going here and simplify this and make it smaller, but I'm not going to. I just wanted to, it's more about like how to get it started and go from there. Your answers will look a lot nicer than this one. So let's talk about the exponent here. So when I am doing these, the first thing you have to recognize is the exponent negative? Because if it is, it becomes 1 over, and we have the same thing, 4x to the 6 over 3 over 2. So that negative is gone from the exponent. All right, now when I do these, I look at it more like 4 to 3 over 2, and then, well, times 6, or x to the 6th, 3 over 2. This just kind of reminds you that that exponent 3 over 2 belongs to the 4 and it belongs to the x to the 6th power. So 4 to the 3 over 2, most people don't realize that you can square root, you can cube it first. It doesn't matter. You could cube root it and then square it. But mostly, if you have it nice, like we already know that the square root of 4 is going to be 2, that's what I'm going to do first. Once I do that, 2 cubed is going to be 8. All right, and then whenever you have an exponent within, or with exponents on the outside, you multiply these by each other. So we're going to end up getting x to the 18 over 2, which is 8x to the 9th. And do not forget that that is over 1. All right, and that's only over 1 when you have a negative exponent here. This just helps to make sure that the exponent belongs to both the number and the variable inside. All right, expressions. This should be very quick. Whenever you have a square root, cube root, fifth root, whatever, that goes at the bottom of the exponent fraction. So the 5 will be on top, and we will have 2 on bottom. So that tells me it's the square root of v to the 5th power, which is what we have here. Okay, and you'll do the opposite here. That 3 is underneath. That means it is a cube root. We have r, and I will go ahead and just put squared on the outside. All right.